So we are going to talk about persistent data in Java applications and the use of ORM, right? So any application you need persistent data, but unlike the frameworks like struts or spring, where you can choose between one of these frameworks easily, it has not been so for persistence. So it has been a topic of debate in Java community, right? So now when we talk about persistent data, we talk about relational technology, and we also talk about using SQL to persist data. So is the persistence, is that something that is solved by relational technology, or do we need to handwrite the basic CRUD operations using SQL? And what happens for different SQL dialects? How will you manage between different SQL dialects, right? Or we should ignore SQL, right? So you can't directly connect to relational technology. Anytime we say persistence data management, we mean writing SQL queries. So can we just drop SQL and then start using start using some other technology? Now, among all this is the concept of Object Relational Mapping ORM, for which Hibernate is an implementation. So Hibernate is a very complex, is an ambitious project to solve, to be the complete solution, to solve the problem of managing persistent data in Java, right? So like I said earlier, again, persistent means using SQL to store the persistent data. So the SQL is run on relational databases, right? So relational databases, why if let's say that you turn off your computer and your server, and the data should now be should live longer, right, than after you have shut down your app by shutting down your computer. So this data is required to be shared among other applications. So that's where relational technology comes in, and like I said earlier, is a primary requirement for several applications, right? Now let's try to see, let's say, let's take let's take SQL, right? SQL, you need to know SQL and Java and JDBC in order for to be able to write uh, good Hibernate, to use Hibernate in a better way, right? So SQL, as you know, it has the DDL and the DML available, and you have to use, if we use SQL in Java, we say that we are using the Java connectivity, database connectivity API, right, which is used to, which the JDBC helps you to prepare, to get a connection, to prepare a query and bind parameters to the query, uh, to execute the statement, to iterate the result set and get data from the result set, right? But as you may realize, it is difficult when you have to do this for each and every domain object you may have, right? So that's where you have, it's also complicated in the context of object oriented applications, right? So that's what we are going to talk about, because Hibernate comes in to bridge, to be a bridge between the object-oriented programming language and the relational technology that uses SQL. Right now we have something called the paradigm mismatch. So in the paradigm mismatch, let's say that you have a user table. Now the user table has username, then first name, last name, address, and billing details, right? Which could be a set of billing details. You can have billing address, you can have several billing, you can have several addresses, billing details related to several credit cards or bank accounts you have. And you have the billing details may contain elements like account number, account name, account type, right? And it also has a foreign key to the user. So you have user, private user, right? Now just talk about, let's take for example the address. So address can be defined as a class in object-oriented programming. But what is the type of address? How is address stored in a relational database? So can we use an address table? It may not be necessary, right? You can have an address class. That doesn't mean that you need to have an address table, right? Because it is always common practice to have addresses along with the user table. So how you write it is you divide the fields that compose the address into multiple columns, like address, street address, city address, state address, country address, zip, etc. Right? So that is called the problem of granularity. On one end you have, so on one end you have two different type of uh, you know two different two different granularity here. So you have fine grained and coarse grained objects, right? So you have address, you can't have an address type. So if you can have something called an address type, user defined data type, which some in olden days used to call object relational extensions, which is not very much supported by by every database. So there is no such thing. So what we have is, like I said earlier, to split the address data into multiple columns, whereas on the domain model, object-oriented model, you have an address class which contains each of these classes. So you have fine-grained classes and you have coarse-grained classes like user, right? So you have user, which is a coarse-grained entity class, and you have a fine-grained class like address, right? So this is something that is quite different, because you have coarse-grained model, because you can't have address inside of the user, and you have a fine-grained class like address. So persistent mechanisms don't many persistent mechanisms do fail to recognize this mismatch. So let's go move on to mismatches due to the object-oriented nature of the application. So you have subtypes, right? So you have inheritance, you have superclasses and subclasses in object-oriented programming. So let's say you have billing details. So billing details can have subclasses like a bank account or a credit card, right? So does SQL have super tables and sub tables? No, you can't have. You do not have such provision with SQL. So what happens is you have an inheritance and you have separate classes. And how do you map? So how many tables do you have to define? Because you can't have have one table extend another table, just like a class extends its abstract class. So that is what is called problem solving using mapping class inheritance, right? There are three types of class inheritances to map the class inheritances, which we can see later. The user, similarly, the user has associations, right? So he has association with billing details. And at runtime, let's say you pick up an instance from user, you get an instance of billing detail. So it could be either a credit card or a bank account. So you need to get that exact data. The query should know which instance of the subclass is this referring to.